This video is going to derive and use the distance formula. Perhaps you've seen the distance formula before, maybe not. It's one of the more commonly used features in mathematics. And the formula that we're going to derive here is working with two dimensions. So again, in an X and Y plane, always remember your axes. This formula actually extends to any number of dimensions. So n dimensions, 4 dimensions if you can even think about that. And so I'm also going to be working with 2 points. So I want to find the straight line distance between P and Q. And I'm using general notation here, x1 and y1. If it helps you to use concrete numbers, go for it. So you could do like 3 and 4, for instance, and then something like 8 and 12. I'm just picking numbers at random here. And they could be reversed. It's not going to much matter here, and we'll see why. Okay, so again, if I'm working with 2 points, so I'm going to say I have my first point located x1 comma y1, so the intersection of those two values on our directed number lines. And then, so this is going to be point P, and then maybe Q is a little bit further out at x2 and y2. Again, I'm assuming that the values would fall like this, and again, it's not going to much matter once we get to the formula, okay? And so what I'm trying to find is a straight line distance d that is between P and Q, okay? But now to do that, well, we don't know how to do that exactly, but maybe I can use a very famous theorem that I know everybody's seen at least once in their mathematical career, the Pythagorean theorem. Okay, so we have a right triangle. So again, a right triangle 90 degrees is one angle. And then it says we look at the legs. So the A and B here are the legs, the shorter two sides of the right triangle. And we take the sum of their squares, and then we say that the sum of their squares is equal to the hypotenuse squared. So C is the hypotenuse, the longest side of the right triangle. Okay, and maybe we can use that here. So what I want to do actually is I want to make a right triangle. And how do I do that? Well, I remember that the Cartesian coordinate system is a rectangular grid. So let's see if I can make, let's see if I go over, if I just look at horizontal movement, and then if I just look at vertical movement, okay, this is actually going to be a right angle. Okay, but the question is, how much are each of the legs? How far do I go over here and here? Okay, well, if I think carefully, I can actually find these values out. Okay, in the horizontal direction and moving from x1 to x2, that would be the difference between them, right? So if I'm working with my numbers, if I had 8 and 3, I would move a total of 5 units. That would be the difference of 8 and 3. So it would be, this is actually x2 minus x1. Similarly, you can do the same procedure with the y's, and this would be y2 minus y1. Okay, and so then I'm going to use the Pythagorean theorem. So again, if I'm thinking c squared is equal to a squared plus b squared, okay, c squared, well, that's just d squared. That's the hypotenuse of my right triangle. And then a here, it doesn't really matter which one you use. I'm going to use x's first. So it would be the quantity x2 minus x1 all squared, okay, because that's the length of this leg, and then some parentheses y2 minus y1 quantity squared. Okay, but I want just d, so in going from here to here, or in going from d squared to d, I have to square root both sides. and I end up getting d is equal to, now technically whenever we introduce a square root we're going to have a plus and minus, but distance, we don't ever think of distance as a negative quantity. It's kind of weird to say you go a negative distance. There's a related concept in physics called displacement for another time. And that can be negative, but distance is always positive. So we're going to say distance is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And that's going to be our distance formula. Okay. So we've derived it. Let's go ahead and use it. Okay, so this is just kind of a summary of what we just found. So we have 2 points. We got a distance formula. This is on your formula sheet. And so now we want to just use it. Okay, so we want to find the distance between -1, 2 and 4, -7. So again, if I label my Cartesian coordinate system as x and y, okay, so I want to plot the points first just so I kind of get a visual representation. So -1 and up 2, okay, so that would be my first point, and then I could label that as P if I wanted to, and so this is P, and Q is going to be at 4, 1, 2, 3, 4, and then down 7, so 4, 7 down here, and so that's Q, and the straight line distance, and this is going to be kind of straight. Okay, well, imagine that was a straight line perfectly, and so that's going to be my D that I want to find. All right, so now I just need to use the formula. Now, if it helps you to identify x1 and x2, go for it. Okay, and I should label this as Q. This would be x1 and y1. It doesn't matter the order in which you do this stuff because of the squares. Okay, you can actually, so I'm going to label this as x1, y1 and x2, y2. So if you happen to flip them around, the square is going to take care of the negative or the opposite ordering. Okay, so don't worry about flipping around as long as you always use the first ordinate to represent x1 or an x value and the second ordinate to represent the y value or the y ordinate. Okay, so going ahead and plugging this all in. All right, so difference in the x is x2 would be 4, and then subtract a -1, square that, plus, and then, let's see, it'd be -7 minus 2 quantity squared. All right, so square root. Doing the math here, PEMDAS, order of operations, 4 minus a negative, that would be 5 quantity squared, plus, and then -7 minus 2 would be -9 quantity squared. And let's see, so working vertically, so 5 squared is 25 plus 81, and if you add that, you get the square root of 106. Okay, and actually that's as simplified as you can get. So just for your reference, don't copy this down, but you would say this is 2 times 53. Okay, both of these are prime numbers, so you can't simplify it any further. All right, so normally you would want to reduce this. So for instance, if you had something like 400, I don't know. Actually, that's a perfect number, or that's a perfect square. So you would write that as 20. But if you had, say, 200, okay, you had to actually have to write that as 10 radical 2. Okay, or square root 2, my apologies. So try to simplify these square roots if you can. Sometimes you're not able to. That's a brief introduction to the distance formula, how it was derived, and how to use it.